Hi, my topic is performance analysis of equalization techniques for wireless communication. In fact, I'm going to examine this in the following order. This is the whole structure of my presentation. My presentation will include introduction, system model and techniques, simulation and experimental results, and conclusion. So let's start from the introduction. Time-dispersive channels can cause hint-symbol interference, a form of distortion that causes symbols to overlap and become indistinguishable by the receiver. An equalizer attempts to mitigate ISI and improve receiver performance. This is the block diagram of a MSA equalizer. The frequency response of the equalizer that compensates the channel distortion can be described by this formula. To enhance a filter, let's consider the sample FIR equalizer output. This can be described by this formula. The response at the output of the equalizer is the transmitted symbol AM. The arrow is defined as Z minus AM. The mean square arrow can be described here, and the correlations are defined as this relationship. The minimum MSE solution is obtained by the differentiation the expressed behind. We can find this formula. We can say that yk equals to xk and plus vk, where x is the channel response and v is the adaptive noise. When you generate the equation above to all the metrics, we obtain these formulas. This is the block of linear adaptive equalizer based on the MSE. The set of linear equations to solve in order to determine the equalizer may be expressed with these matrix here, where B is a 2k plus 1 times 2k plus 1, and C is a column vector, and D is also a 2k plus 1 column vector. We can admit that a good value of delta in order to enhance convergence and good tracking capability in slowly varying channels, where PR denotes the received signal pulse noise power, which can be estimated from the receiver signal. Then we can run programs. The first one is MSE adaptive. MSE equalizer. And the second one is adaptive equalizer. Then let's see the simulation and experimental results. Figure 3 shows the results of MSE equalization of the signal xt. We can find that we get a good result which is as satisfying as the one obtained with a zero-function equalizer. This could be our basic result, and it will be compared with other signals below. The equalizing window is going to be finite. The reason is that the larger the window is, the higher the number of equations to solve to get a good equalizer is going to be. So, when the length of the window is increasing, the difficulty for solving these equations will increase too. We can see that MSE equalizer is better at NO equals to 0.1, NO equal to 1, and NO equal to 10. With the NO increasing, MSE equalizer shows perfect properties. Figure 6 shows the superposition of curves for two values of delta. N and num of realizations are states with respect values 180 and 1000. We can find the influence of delta value. With increasing the delta value, the mean square error increases, which seems to be not a good result. This result shows that decreasing delta value may be a good choice for adaptive equalizer. Figure 7 shows the result when n changes to 100. We can find that the curve has a mean square limited when we decrease the number of iterations. Figure 8 shows the difference between equalizer with realization value of 1000 and 2000. The curve of the value of mean square error of realization value of 1000 is not enough smooth compared with the case of realization value of 2000. This means that the second equalizer could be a better choice. On the other hand, on the sector curve, there are no obvious peaks, which means that the coefficient of the second equalizer should be better. Finally, let's say the conclusion. In this project, we designed two kinds of equalizer, MSE equalizer and adaptive equalizer. We tested the effect of these two equalizers through change important parameter. Influence of equalizing window on MSE equalizer has been found, and noise experiment shows that MSE is a good equalizer. On the other hand, adaptive equalizer was tested, showing that the number of data and iterations have great effect on adaptive equalizer. Our result is identical to the theoretical analysis. So, thank you so much.